We just got a couple examples left for section 2. Sulfur dioxide is going to react with oxygen and water in this next equation to make sulfuric acid. It is how acid rain is formed, as you can read from the question. But for our purposes, again, we just need that reaction. We need that equation. We need a balanced equation. So I got to make sure I can figure that out. Seeing as there's 1, 2, 3, 4, 5 oxygens on the left, everything else is kind of balanced, so I can't really do anything else first. There's 5 oxygens on the left, only 4 over here. I'm just going to start out with a 2, see what happens, because then I have 2 waters and 2 sulfur dioxides, and that gives me 4, 5, 6, 7, 8 oxygens, 8 oxygens on both sides, so that worked out pretty nicely. 2, 1, 2, 2. And the actual problem itself is asking me what mass of sulfur dioxide is needed to react with 37.50 moles of oxygen. So again, I'm given moles, and I want a mass. So just like the last problem, if I start out with moles of some substance, it doesn't matter what it is, we're just saying A, generically always, right? If I want a mass of some other substance, I'm going to have to change moles of A into moles of B first. So it's just one more example like that last one. I got to change into moles of B before I can turn those moles, into grams of B. Again, I'm going to have a similar looking work because I need moles of A here to cancel. I need moles of B here to cancel. So I have a mole ratio on my first step that is going to be B and A. Again, I'm starting with oxygen and I want to know about sulfur dioxide. So it doesn't matter that they're both reactants or if one's a reactant, one's a product. Anything in the equation can be related, so it doesn't really matter where they are. But I also need a molar mass for B, which is something I'm going to have to figure out. Since B is sulfur dioxide, I have to add up those 2 pieces on the periodic table, and it turns out that 1 mole of sulfur dioxide has a mass of 64.07 grams. That's a 32.07 for sulfur and 2 16s combined for oxygen. So again, I know what I need. Now I just got to work with it. Now I just got to set up my problem and actually get the answer I'm supposed to get. So I start with 3.75 moles of oxygen. My first step is to do the ratio B over A, and B is sulfur dioxide, so there's 2 moles of sulfur dioxide for every 1 mole of oxygen that reacts. And then I need to convert grams into moles. So 64.07 is my mass for sulfur dioxide, and that's 1 mole of sulfur dioxide. This is always a 1, by the way. Some people get confused by that. Just because this was a 2 here doesn't mean this has to be a 2, right? When you're doing your molar masses, it's always 1 mole of sulfur dioxide. Don't make it 2 or else you screw everything up, right? So I have my work. My units cancel appropriately. I'm going to get grams of sulfur dioxide as a result, which is exactly what I wanted, a mass of sulfur dioxide. So I just multiply and divide and get an answer. In this case, it's all multiplying because you don't have to divide by ones. But 37.5 times 2 times 64.07 apparently is 4,805.25, right? I don't need that many sig figs, so I round appropriately, right? According to 37.50 up here, I need 4 sig figs in my answer. So I am going to keep that much of the number. It's actually going to be 4805 grams of sulfur dioxide, right? Maybe a question would ask you how many kilograms of sulfur dioxide, since it's a really big amount. Maybe you'd write it as 4.805 kilograms of sulfur dioxide. It's the same answer, just a different unit. So That's that example again. As long as you understand what we're doing, what we're converting step by step. I'm using a mole ratio first, then a molar mass. I know how to figure those things out. Use your periodic table. To come up with this number here, right? You got to add up those pieces, 1 sulfur, 2 oxygens to get that mass. We should know how to do that already. Otherwise, we can go on to the next example. So chlorine gas can be produced by electrolysis, it looks like, but you have an aqueous sodium chloride solution. So sodium chloride is reacting with water to make sodium hydroxide, chlorine, hydrogen. Got to balance this whole thing. It looks to me like chlorine's the biggest problem to start out, right? 2 means I need 2 here, which means I need 2 here, which means I need 2 waters, and now I have 2 oxygens on both sides, 4 hydrogens on both sides, and should be good to go. So 2, 2, 2, 1, 1. That's how this balances. Again, I have a problem in here. I want to know how many moles I can get from grams of sodium chloride. So this is a little bit different than the last problem. So I'm going to need to start with grams of something. That's what I was given. So I have grams of A. And I want moles of B. But again, if I go way, way back to what we started with, right, this idea here of what I can change into what, if I have grams of A, I can't turn it directly into moles of B. I have to turn it into moles of A first. So I got to remember my string. I can go from grams of A to moles of A. Then I can change moles of A into moles of B. In order to do that, I'm going to have to show some work. And I know I should have grams of A there, moles of A here, because this needs to cancel this. Grams need to cancel grams. I know that I got some ratios in there. Again, this is my mole ratio, which in this, excuse me, sorry about that. I meant to hit this thing over here. That's my mole ratio, A and B, which I'm going to use my equation for up here. Right? B in this case is chlorine. A is sodium chloride, so I need numbers from here and here. It's a 2-to-1 ratio. I also need a molar mass. And that molar mass needs to be for substance A, for sodium chloride. So I need to know what the mass of 1 mole of sodium chloride is. So I have to use my periodic table, add up those 2 pieces. Sodium plus chlorine gives me 58.44 grams. So I'm going to use that conversion factor in my work. And then I'm just going to do what I got to do. I've already figured out what I need. I know what the work should look like. I just have to start filling in with what I know. So this is my starting mass, 250 grams of sodium chloride that I dissolved in water and then ran some electricity through it. So 250 grams. Now I have a molar mass to use. I'm going to put the mass on the bottom, 58.44 grams. And that's 1 mole. And then I'm going to do my mole ratio. I got to put B over A. B is chlorine, so I put 1 mole of chlorine over 2 moles, excuse me, I about wrote 1, of sodium chloride. And once I do my work here, once I multiply and divide, I should be left with moles of chlorine as an answer, which is exactly what I wanted, so that should be good. And I just have to use my calculator to come up with an answer. So this time I'm dividing instead of multiplying, but 250 divided by 50-ish, right, and then divided by 2, right? Use your calculator to get an exact number. Apparently it's 2.1389, right? Again, I don't need that many sig figs. I'm just writing them down just in case. I actually need 2 sig figs because this number has 2 sig figs. So I'm actually going to write an answer of 2.1 moles of chlorine. Excuse me, I forgot my L on the moles. But then notice that this also asked me for another thing, right? It asked me how many moles of hydrogen would be produced. So don't forget to answer both parts of a question. I might ask for two different things, but also don't forget to use your brain, right? If I want moles of hydrogen, and according to the balanced equation above, I can relate chlorine and hydrogen just like I can relate sodium chloride and chlorine. And if those two relate in a 1-to-1 ratio, if I'm going to make 2.1 moles of chlorine, guess how many moles of hydrogen I'm going to make? Because it should be a pretty easy answer to come up with, because it should be the same. And if that's the case, go ahead and go with it. Write it down. You don't have to show all your work. Now, if you ever do that, if you skip work, because I'm going to grade work on this next quiz, test, whatever assignment that you're going to do, right? Because anybody could ask somebody else what the answer is, but if you're going to copy, I'm going to make sure you're copying all the work too, right? If you only show the answer, there better be a 1-to-1 ratio next to it as your work, because I can understand how you got from here to here, but only if you write 1-to-1 ratio. Because, Johnny might write down 2.1 moles and 2.1 moles because that's what Jimmy had on his test, right? So make sure you're showing your work, because you're not going to get credit for anything if you don't show your work. So if you ever skip a step, if you just use a 1-to-1 ratio idea, go for it. That's fine. But you got to show me how you got that answer some way, somehow. So at the very least, write that next to your answer like I just did. Next problem. Sodium peroxide reacts vigorously with water in the following unbalanced equation, right? Yeah, we're already over 10 minutes. I'll quit and have one more.